everyone. Mansa here, welcoming you to a special episode of our podcast powered by Smartbots. We have two trailblazing guests joining us today for an in depth look at retrieval augmented generation, popularly known as RAG, and how this emerging AI capability promises to transform enterprises. First up, we have Chia, a visionary entrepreneur, former venture capitalist, and Forbes 30 Under 30 awardee. Great to have you here, Chia.
Thanks for having me. Good to be here.
Great. And joining us is JP, the co-founder of SmartBots AI, bringing valuable insights from forefront of AI innovations. Welcome, JP.
Thank you, Mansa. As usual, it's a pleasure to be here.
All right. So, Chia, could you give us a quick brief about the exciting projects you're working on now and what's coming on your end?
My name's Chia. I'm one of the co-founders of AI. We are helping to streamline knowledge graph creations in RAG pipelines. And we had initially found the need for better determinism and structure within semantics when we were trying to build RAG systems for multi-document legal cases, and realized that being able to build more and more mapping of your data and structure in the way that the LM processes words was really, really important. And that's what we're working on at the moment.
Thank you, Chia. And JP, what are some of the promising AI capabilities at SmartBots that have you most fired up at the moment?
Hello, all. I'm JP. I'm a solution architect and co-founder at SmartBots. And so the past 1 year has been really crazy. And these days, what I'm primarily focusing is interacting with enterprises and helping them deploy RAG-based solutions. So as we all know, that RAG is one of the most promising enterprise solution today available. But on the enterprises side, what we keep hearing is there is a lot of gap in terms of their understanding, the challenges in terms of the security aspects. Even if you're looking at a basic document search using RAG implementation, enterprises are facing a lot of difficult questions to productionize these solutions. So these days, I'm working with the enterprises, helping them out, solve this, answer few of their questions, and help them deploy a production grade RAG solution. And that's what SmartBots and our team is busy these days. At least for the past 6 months, this has been our focus.
Thanks to both of you for sharing current insights. And let's now focus our talk to unlocking the potential of RAG, an area of great interest. And JP, over to you to walk us through what RAG is all about and why enterprises should care.
Sure. The way I want to structure this conversation, Chia, is try to understand from an enterprise standpoint, provide value to the enterprise who are in the plan of implementing RAG solutions within their systems. So to start with, I have a kind of a structure to this discussion where I want to primarily focus on the enterprise use cases, see where RAG can be of value, what are the advancements in RAG, and what is the future potential of RAG-based solutions for enterprises. So that's the primary scope of how I want to structure this discussion. So to start with, what I would like to understand from you is about the as we call the traditional RAG, which is not actually which is not very old. It is like 6 months old. When we were talking about, say, doing a chunking strategy, following a chunking strategy, there's still a lot of discussion around what should be the right chunking strategy. And the doing a cosine similarity, finding the right chunk, doing some more layers of interpretation. So if we call that as the traditional RAG approach, first of all, if you can correct my definition of traditional RAG, if there's anything that you consider to be traditional in RAG, and then also maybe if you can put your thoughts around what are the challenges that you have encountered in this chunking based RAG approach.
Yeah, absolutely. I think what you're referring to is around simple RAG or naive RAG, as it's called, and where I think the use cases and retrieval process is relatively straightforward. Typically, you are dealing with a scenario where, for example, you might be querying against the pre-existing question and answer base, and where the answers that you're looking for, the questions that are being asked, typically very straightforward, and is really using DLM for relatively minor semantic similarity search, and that exists. And so, of course, we do still deal with things like chunking, etc., for more complex RAG scenarios. But I think there has been an increasing number of cases where the range of scenarios where simple RAG is insufficient, such as where you are looking for a high level of determinism, where the questions may vary far greater than the LLM can necessarily handle and be able to contextualize, and where there may be, for example, a more complex data set that you are looking to look through. For example, it could be that there are step-by-step reasoning processes within the information retrieval processes where there are certain SOPs that need to be followed in this particular way when reasoning through the information that you are obtaining, or where there are multiple documents where information can be pieced together. There's a wide range of scenarios where complex RAG may emerge, even for relatively outwardly straightforward cases. And that's, I think, some of what a lot of people in the industry are thinking about at the moment.
Sure. So what I hear from you is that there is a simple RAG, which still is good for few use cases, and you also have more variations or more advanced versions of RAG. There may be an intermediate version and more advanced version. In a simple RAG where you do basic similarity using LLMs or some prompts. And then in the intermediate version, we have chunking strategy, and this chunking also mechanisms you can use different ways of chunking by paragraph, chunking by pages, so on and so forth, which fits the use case. And maybe the advanced version is what you have initially mentioned is using knowledge graphs where you take care of a lot of pre at the build stage you do a lot of work which will understand more from you. Is that a right categorization? A simple, medium, complex, and then complex RAG implementations?
Yeah, for sure. I think that's a good picture of it. I think I would say it's a spectrum as opposed to neat categorization. I think, for example, that a good chunking is best practice, kind of regardless of the complexity of the question. But absolutely, I think what you're alluding to, which is really reflected in the industry, is the fact that as the questions and data become more and more complicated, more and more techniques need to be added on within the existing RAG pipeline.
Awesome. So again, for this discussion, I would like to call out a few use cases from the enterprise which I have encountered chatting with a lot of enterprise customers. I'll just read them out. Maybe that I'll use as the reference for our conversations further. And what I would like to understand from you is which would be the most appropriate way to handle this kind of enterprise use cases, whether we should go for a simple one or a medium complex one or a complex RAG solution. So the cases, the enterprise cases that I keep hearing is about six different types of different cases. One is the standard knowledge management within an enterprise. So for an internal user, be it an employee or a contractor or primarily someone within the enterprise, where they are looking for or searching for a specific document. I call it the knowledge management internal use case. That's the first one. The second one is the customer support use case where you are having a chatbot where there's a support system, there are CRMs and all, and product documentation as well, where you use product. We implement RAG for helping the customers. So this is the customer support use case, two use cases. Then we have compliance and audit, and that is the third category where streamlining the search for a specific regulation or standard across vast repository of legal and policy documents. So that is the third kind of use case. And there are three more, but these are the first three. I would like to pause here and then ask you, like, say, if you take these three use cases, one knowledge management internal use case, customer support for product documentation, and then the third one is compliance and auditing. Now, if you pick these three use cases, how do you try, like, if you have to solve this using RAG, what kind of approach would you take? Which kind of approach will you take? A simple one, a medium complex one, or a complex one?
Yeah, for sure. So I think this is the kind of question that I do get quite a lot, and I think that it's really difficult to categorize it in this way. I think that the fundamental thing that you're trying to solve for is accurate information retrieval, which requires looking at the complexity of the question, the complexity of the data set that you're looking at, and specifically what types of questions are necessary to be answered. So as an example of this, you could completely imagine that while compliance use cases might typically be the most complex, it might be the scenario that this company actually has a very limited set of compliance questions, very straightforward set of compliance questions that they typically ask. And legal counsel, for example, has already prepared answers for that. And so it's really, trying to perform information retrieval over what we would call, something that's a prepared data set with very, very limited set of questions. And therefore, it's a very straightforward information retrieval process. And you can imagine that while, chatbot customer support is typically a very straightforward process because you typically already have existing Q&A pairs. The range of questions is known. The range of answers is also very straightforward, and there's not much deviance. It could be the scenario, and we've certainly met plenty of clients which surprised us, which have multi-hop information retrieval needs, multiple reasoning needs, and multiple kind of reasoning navigation needs as a result because of just the sector that they're in or the way that the data was prepared, the way that the customers or business is prepared. So I think that it's really, really hard to generalize, and it's a function of the specificity of the questions involved. And typically what we see is that in almost every single use case, we'll see about 80% of the questions which are relatively straightforward and simple, and then about 20% of the questions are really complex and hard to manage. And that's something that we see kind of if you're doing something super complex or if you're doing something super simple, there will always be a range of complex versus simple questions to deal with, and dealing with them kind of involves very different techniques, and hence why kind of RAG is a relatively straightforward process in theory, and kind of under the hood, there's a fair bit of engineering that happens.
So what I hear from you is that RAG, from an enterprise standpoint, it really depends on the nature of the use case, and accordingly, it could be even a simple customer support use case, but we might have to implement complex RAG-based implementations where you might have to go to the advanced features of RAG, where say your area of expertise, which is knowledge graphs, might be needed even for a simple use case. And is it a fair assumption to take where, say, enterprises, if the complexity of the questions is not too much, say you're saying 80% is simple, 20% is not. So, have you encountered any conversations with enterprises where the 20% is considered as long tail? Let us ignore it, only focus on the 80%, which is most of the common queries that come, and let us implement using RAG so that we are able to handle most of the conversations in terms of volumes, and 20% is the long tail, so we will not be much worried and quickly turn around and show some results. Is that something which you are hearing in the industry?
Yeah, I do think it depends very much on, what the use case is, but I think your that intuition is absolutely right for kind of some simpler use cases. So as an example of this, I think Klarna very recently launched their AI bot, or at the very least, I discovered it a little bit too late when the news came out. And within the Klarna use case, you can see that the decision flow is actually a very traditional one, where there are a set of specific questions that they would like the AI to be able to tackle, categorize, and then answer. And there is, when I tried to experiment with more complex questions for the Klarna bot, it very cleverly decided to say that they would like to redirect this to a human call center support person to be able to assist my request. And so that's one great example, as you mentioned, where there is a set of very simple questions that I think they want to make sure that they can automate the categorization and answering of. And then being able to say there's a long tail of more complex questions because there's a high variance of that type of long tail questions due to the large consumer base for Klarna, being able to say this is something that a human should be able to handle. Now, there may be use cases where the automation of RAG makes sense only if you're able to also answer these complex questions. And that's something that we do see, where a lot of our design partners have been very interested in making sure that you are able to answer really all of the relevant questions before they see business values in adopting this. And that's certainly something that we also see quite a fair bit. So I anecdotally would assume that kind of phenomenon that you described would matter a lot more in kind of consumer facing customer support use cases.
Sure. So I would like to go into the technicalities of how this advanced capabilities of RAG and how would that work. But before that, one more question I have again from the business standpoint on, are there any cases that you have encountered where the advanced capabilities are must have, not a good to have, or cannot be ignored as a long tail? For example, if we take legal or research processes, where the traditional, the simple RAG as we call it, might not be a fit, and it's like a deal breaker if without advanced capabilities. Have you seen such use cases?
Yeah, I think you're exactly right. Legal is a great example of one where frequently your even very simple, innocent questions will likely require some kind of very specific retrieval processes or multi-document retrieval processes, because you might, for example, have to refer to another document. You have to refer to one document and then compare that to a second document and potentially compare that to a third document, blah blah blah, being able to come up with an answer due to the way that contracts are written, where they're always referring to something else at a different part of the contract or a different contract altogether. And so in that case, it is really important for kind of complex techniques to be implemented here. And being able to say that, let's have a lawyer intervene may diminish the value of the information retrieval system here necessarily.
So yes, now looking at these advanced techniques of using knowledge graphs and using some more techniques that you have called out in your blog, can you help us understand how does that work? If you are looking at compare it with the simple RAG, if you are using knowledge graphs, what exactly are knowledge graphs and why? What role do they play in RAG-based solutions?
Absolutely. So knowledge graphs are one, I would say, of many different ways that complex RAG could be implemented. And so I don't want to say that knowledge graphs are the only way. It's certainly what we think is one of the more promising ways to implement it in an enterprise setting, because it's one of the more deterministic solutions out there. And so knowledge graphs are conceptually very simple. They are basically a deterministic store of relationships between concepts and entities, and are able to help you have a better understanding of what do certain words and associations mean when you mention them, and how to think about navigating fundamentally words. And the reason it's very useful is because, as you mentioned earlier, cosine similarity or semantic similarity may not necessarily refer to relevancy. And so being able to impose a structure in the way that we think about retrieving words, or the way we think about navigating words to retrieve, is really important. And the, I think, probabilistic nature of LLMs makes kind of retrieval a little bit of a black box, and obviously there are ways to control it. That probabilistic nature, I think, does offer a little bit of worry to enterprises who are trying to adopt LLMs in a widespread and accurate and deterministic fashion. And so being able to impose knowledge graphs on top of your data to aid with more accurate retrieval, or to aid with more deterministic retrieval, or being able to impose knowledge graphs really as a long-term knowledge base, long-term structured knowledge base, is something that I think a lot of people are very interested in, because of the ability for deterministic accuracy and also explainability of specific types of reasoning.
Okay, I'm still trying to understand. And here, when you say that knowledge graphs are a graph which are connecting concepts and entities within the document, is that something which is happening at the build time, meaning at the when you do the job of uploading the documents, then the knowledge graphs gets created just like how vectors get embeddings get created and then stored in a vector database. Similarly, do knowledge graph also does it get created at the build time and get stored somewhere? And consumed while in the runtime when the user is actually interacting with the solution, or is it done real time?
Sure. So we've, having scanned the market and also developed a bunch of techniques ourselves, we've identified like 9 different ways that you would use a knowledge graph. I'll just talk about two very briefly, but the answer to your question is really both, depending on the technique and depending what you're optimizing for. And so one of the techniques is really being able to use a knowledge graph that is created once your document's uploaded, to be able to create a document hierarchy or concept dictionary of the underlying unstructured data. And this is in order to perform deterministic chunk extraction, whereupon you are able to write rules to enforce chunk extraction for specific types of questions. And so this is a way to imbue and point the LLM into the right direction for relevancy, for relevant chunks when they're performing certain types of queries. And so in that sense, that's a knowledge graph of metadata that is done kind of once the document is uploaded and before any query is created. We also have seen and also been building up to tooling for recursive retrieval for what we call just-in-time knowledge graphs. And so these are knowledge graphs that are spun up, that are completely contextualized to a specific question. And so you're essentially creating a graph each time that a question is asked, and being able to structure that specific answer, and being able to allow that mini knowledge graph to be part of an increasing growing knowledge base that you have each time a new question is asked, and being able to perform a unified graph on the back each time each question is asked. And so your structured knowledge base grows over time.
Okay. So if you're looking at you've mentioned that knowledge graph is connecting concepts and entities, correct? How do you define a concept or an entity? Is it like a chunk that you are taking and then considering that as a concept, or concept as such has a different definition? And what does entity mean? Does entity mean like the list of products in the product catalog, or is it like it could be any element that has this kind of a product name kind of a nature? What is can you help define these terms?
Yeah, for sure. So I think your intuition is roughly correct. What I would say is the what we are trying to make sure to do is to make sure that the nodes and relationships and the ultimate triples that are created fundamentally contextualize and relevant to your domain, to the questions at hand. Now, one of the things that we have conversations with folks on is really the fact that being able to capture all relationships and all entities is obviously possible. It can be done, but I think the purpose of RAG is to be able to make sure that they are taking in only the right context. And so sometimes, while it may be advantageous to create a giant knowledge graph of all your unstructured data and being able to map all the entities and relationships, I think what we find is that in many cases, it's also it's more advantageous to be able to reveal and map the relationships and entities that are only relevant to the question and domain at hand. And so, yes, you're absolutely right. For example, the nodes in the product catalog is almost certainly going to be the products themselves. As an example of a node, that there may be other have nodes and relationships to map depending on the questions. And then yes, the entities, the kind of relationships to map is again very dependent on the question at hand and context at hand. But it could, for example, be the price of the catalog that they're trying to track.
Sure. So, and this is under the hood, right? So, the nature of the knowledge graph or the entities that are identified is based on how you give the configuration of the knowledge graph, maybe based on the use case. It is not something which when we are implementing RAG, we don't have to pick and choose. The system will determine these are the entities, these are the relations, these are the this is how the graph would be, and that is something which is black box for us. Are there any ways to like influence that knowledge graph? Say if you feel that okay, from the product catalog, when you have implemented the solution, few of the entities which you think have to be identified are not, can you influence that and then tweak it and influence or maybe customize your knowledge graph as per your understanding of the domain?
Yeah, no, I appreciate that question. Actually, that's exactly what we are building too. So while automated knowledge graph creation, I think would be a end goal and something that we're building to, we are very much focused on the realities of constructing this graph, frequently requiring human domain experts to step in and be able to intervene. And so we're very much focused on workflow tooling and visualizations to allow the human to be able to see the relationships and nodes and entities being created, to be able to step in and say that certain relationships, certain entities, certain nodes are relevant or not relevant for certain contexts, and being able to make sure that there are levers to tweak and that the entire process is incredibly transparent and not a black box. So that's precisely the one of the kind of problems or tooling that we're trying to provide in this process, because I think the reality is that while LLMs are really great, there may be certain contexts where they're incredibly unfamiliar and unable to then be very precise in the way that they think about the relationships to map, and human intervention, especially on the domain, non-technical domain expert side, is required.
Wonderful. So, what I hear from you is mostly on the retriever side, you are trying to increase the quality of getting to the right context using knowledge graphs. On the generation side, are you guys focusing, or do you have any ideas around how we can enhance the generation part? I know that we once we get to the right context, giving it to an LLM and then letting the LLM decide on what should be the answer is what I know of the traditional way of generation. Is there some advancements happening on the generation side as well?
Yeah, I think there are a lot of interesting work being done on the foundation models level of things for ontology creation. I think that the biggest problem is still being able to make sure that the ontology that you are creating is precise, accurate, and relevant to your needs. And I think that that's a task that it's hard for even just the average human being due to the specific precision of language that's required. We think that the LM actually does a fairly decent job, and we just want to be able to enhance the ability for the LM to work together with the developer and domain expert to be able to get to that last mile of accuracy. But it is fundamentally a question of semantics, which is a tough and complicated and niche problem to solve for. Like, what are words, what are better words, what are the right words to use in this case, and the right words to track, the right words to store. And that problem, I think, is something that's very fascinating because it's really the intersection of language processing and semantics, which I think is relatively specific area to be optimizing in.
Great. So now I see that knowledge graphs, as we have discussed, is more advanced capability of implementing solutions. So that reasoning is the concept behind the knowledge graph, which will give a better answer at the end of the day, so that users will be able to get to the right answer quickly by interacting with these RAG systems. So I see that accuracy or ability to get to the right answer is something which we get from knowledge graph. Is there any other benefit for the enterprise in terms of say latency improvements or cost, lower cost if you're going for knowledge graph?
Yeah, absolutely. So I think I'll highlight two. I think the first most important one is obviously explainability and determinism. So being able to point out exactly how a reasoning was performed or failed through a graph query is relatively straightforward. And that determinism, I think, is something that people really, really enjoy and are looking for, especially when it comes to enterprise systems, where they want to be assured that there is a very specific reasoning being relied upon when information retrieval is done. And the second thing is also again explainability, because you can also highlight the exact logic that's done. And this is also, it's a little bit different from determinism because you can also see and visualize a knowledge graph in a way that you can't really visualize, for example, chunks, at least to a non-technical person. And so being able to see that logic, I think it gives some assurances to non-technical leaders about what is really being processed here. And of course, you can visualize chunks, but you can't visualize the way that chunks interact with each other and how they're relevant to each other, et cetera, at least not easily. The other thing that you mentioned is, yes, I think costs is certainly one. It's far easier to query, any kind of. It's far cheaper, I think, to perform a graph query, and it's far faster. I think it's always a trade-off. I think the way I think about accuracy is because right now, to a certain extent, it is possible to build very complex systems, simple vector similarity, which can promise accuracy, but latency and cost might potentially rise as a result. And so you're always trying to balance accuracy with costs. And so being able to rely, I think, on knowledge graphs is a great way to be able to kind of do both accuracy at a slightly cheaper. And that's something that I think a bunch of people have also been very, very appreciative of. But I would say kind of determinism, accuracy, and explainability are some of the kind of key value propositions here.
Great. So the value props are, I think that you have called out are really important. I'm sure enterprises would appreciate mainly the explainability part, while the other aspects are something which, in terms of cost and latency, are something which enterprises are still looking into. But explainability is something which is key. And today, most of the LLM-based solutions I'm seeing that enterprises are struggling to get to that explainability part of the solution. That brings me to the other one more topic I wanted to touch upon is on the solutions, the fully managed services like Amazon Q, which kind of is like a magic box where you upload documents and then start interacting with the solution. What is your take on the making this kind of services fully manageable? Now, looking from the enterprise standpoint. Today, I don't see a way of explainability in this kind of solutions. How do you see the future is going to be? How do enterprises, how are they going to adopt this kind of technology?
Yeah, for sure. I think that, it's really heartening to see a whole bunch of enterprises really adopt it. And, some of the large tech companies are obviously pioneers of course, in the space. And I think at the very least, some of the people that we've talked to are still grappling with the complexity of RAG. And so for certain use cases, I think it does make sense to use a fully managed service from one of these large providers. In some cases, it makes a little bit more sense to try to build something a little bit more custom, which is a reflection of the complexity of some of the systems and questions that they're tackling. So I do think it's a case by case, but in general, I think it's amazing and fantastic that we're seeing adoption of RAG and some of these systems more and more across the spectrum. And so I think there's a lot to do in this space and a lot to really learn from each other from that perspective.
Awesome. And one last question before I conclude is the recent announcement of Gemini model, which there were some articles which say that we don't need this complex RAG solutions because of the large context window. And I also read one of your articles on why RAG is still relevant. Can you throw some light on, say, the larger context window models with really massive LLMs? In that context, where does RAG stand going forward?
Yeah, absolutely. And so I think that it's awesome to see more and more innovations in the foundation level model. Competition is great between models and to provide people building in RAG with more better tools for the system. I think what I highlighted in the article was that this is a really exciting development that will actually likely spur the adoption of RAG because the error margin for RAG systems have now increased. I did talk a little bit about how some of the benchmark tests, for example, in multiple needle in the haystack, where you're trying to spot multiple different sentences or within the large context window, had a pretty low recall rate of 60% right now. I'm sure that will improve. But for me, this is a reflection of better tooling that will help RAG systems, and that is still, I think, not super feasible for specific kinds of complex RAG systems to really be adopted by throwing everything into the context window. And the other thing I will say is, I think people are less likely to want, as RAG matures and is adopted by enterprises over time, the optimization level here is really being able to make sure that you're fitting less and less and only the most relevant chunks into the context window for purposes of latency, accuracy, and costs. And that process and that optimization process is fundamentally what RAG is, which is being able to make sure that the right context and information is thrown in as opposed to throwing everything into the context window. So really excited. I think it's awesome to see Gemini 1.5. And I think that will spur on a lot of RAG development. And I think the main thing to be aware of is maybe some simpler RAG systems may not necessarily very, very straightforward RAG systems may have some diminished capacity.
And also, one more point that you have earlier mentioned is about the explainability. Say, if we are taking a large model, and then while we can leverage the large context window, still we'll have the explainability challenge with this kind of solutions. Maybe that's something which enterprises have to consider.
Yeah, absolutely. I appreciate you bringing that up because I think the CTO of Databricks made a similar point about non-monolithic systems as opposed to monolithic systems, because with non-monolithic systems, you can more precisely understand where the system broke down, and you have levers to tweak and fix if, for example, a particular error was made, which is not something that you can do if you throw everything into an LLM and kind of it spits out a wrong answer and you're not exactly sure why.
Yeah, that's about it. I mean, I have covered most of the points that I thought I'll get an understanding from you. Mansa, over to you.
Thank you, JP. And Chia, we have explored numerous dimensions of RAG today. As we conclude, what are one or two higher order insights on RAG's immense potential would you leave our audience with?
Absolutely. I think that the really interesting personal learning for myself through this entire process has been twofold. How much of my general work previously has been really about information retrieval and aggregation. And a lot of that work with complex RAG systems can really be automated. And so that was something that I think all of us kind of in the knowledge management space is keenly looking out for. And then the second thing is really, I'm really excited by all of this precision around language and semantic and language optimization that I think is increasingly becoming more and more of a phenomenon as we are seeing LLMs really transform the way that we communicate and work together and be very precise and using kind of words as the medium for computer manipulation.
Absolutely fantastic insights. And JP, building on the extensive RAG perspective shared so far, what specific guidance or recommendations would you offer to business leaders exploring deployment of this technology?
Sure. First of all, I would like to thank Chia for the all the learnings that I got from the session today. The two learnings personally which I got, one is the advanced RAG techniques will enhance the quality of the output, and the second one is the explainability. Honestly, explainability is something which I'm sure I'll carry to my enterprise customers when we talk about this kind of solution. So these two are my major learnings. And yeah, so for going forward, I'm very optimistic about RAG. I've been investing a lot of time and effort personally on this space. And for the next this full year, we'll be trying to help enterprises deploy this kind of solutions. As discussed during the call, we'll have to pick the right solution for the use case. So be it small, medium, large, whatever is the complexity of implementation is determined by the use case. So I'll take all these learnings to the enterprises, help them get to the right approach, because finally my objective here is to help enterprises get to the right direction, because there's so much of noise in the system. And I'm sure these kind of interactions with experts will help me and smartbots as a company give the right guidance to the enterprises.
Thank you, JP. And with that, our conversation on RAG draws to a close. And I thank our guests, JP and Chia, for sharing the knowledge. And we learned how new RAG methodologies pave the way for more advanced AI with accuracy and predictability, right? To our viewers, join us next week as we track the continuing technology and landscape. Until then, stay curious, stay informed.